So welcome to the 5th video in our series of self-paced learning for General Maths 2. We're going to talk about Hamiltonian circuits and paths in this video. So we've been working with Eulerian circuits and paths which focus on the edges. So you can remember E for Euler, E for edges. E for Euler, E for edges. Now the difference with Hamiltonian circuits and paths is that we focus on the vertices. So a Hamiltonian circuit visits every vertex exactly once and returns to the starting vertex. Hamiltonian path visits every vertex exactly once, finishing at a different vertex. So a very simple Hamiltonian circuit in this diagram, A, B, C, D, E, A. We don't visit either of these edges, but we've been to each vertex exactly once and ended up back where we started. Over here, we do a Hamiltonian path. We start at E, B, D, C. We've touched every vertex, but we've ended up in a different place to where we started. Okay, so for this diagram here, a Hamiltonian circuit starting at A. Okay, I'll go A, B, C, E, D, and back to A. Right, so didn't touch these edges. That's a Hamiltonian circuit. A path, very similar to that one. Hamiltonian path, I'll go A, B, C, E, D. I'll just stop there. That's a Hamiltonian path for that circuit. So I started at A and finished at D. Touched every vertex once. Okay, there's our path and there's our circuit. Alright, so you might want to pause the video and try this problem first on page 23, then I'll have a go at it. Right, so Hamiltonian circuit starting at A. This is simple. I'll just go all the way around the outside. Okay, so there's a nice Hamiltonian circuit. An Eulerian circuit starting and finishing at A. Okay, have you tried that one? Is it possible? Well, of course the answer is no, because we have odd vertices at E and D, and they all have to be even for an Eulerian circuit to be possible. So not possible. Is an Eulerian path possible? Well, yes, because we do have two vertices of odd degree, and we need that for an Eulerian path to be possible. So let's find an Eulerian path. Okay, now you may have noticed that to do an Eulerian path you must start at one of the odd vertices. Okay, so I'll start at D and try that. So we'll go D to A to E, around this way. Okay, back to D and to E. So we started at D and finished at E. So we went D to A to E to F to G, D to A to E to F to G, to A to B, to C, to D to E. So there's an Eulerian path there. Okay, a Hamiltonian path between E and B. Alright, so this will be a path that touches each vertex but starts at E and ends up at B. Okay, so let's see, what can we do? We can only go through each vertex once. Let's go this way. That'll work. So we start at E to F to G to A. Then we went to D to C to B. I only went through each vertex once. Hamiltonian path from G to B. Okay, I think we go like this. Yep, that's not too bad. That'll do. G to F to E to A to D, C to B. Hamiltonian path from F to B. Okay, what can we do here? That's all right. Up to G to A, da, da, da. There we go. So F to G, to A to E to D to C to B. All right, so there are those answers to that one. Explain the difference between a Hamiltonian circuit and an Eulerian circuit. Well, remember E for Euler, E for edges. So a Hamiltonian circuit visits each vertex once, ending up where it started. An Eulerian circuit, I'll just say EC because I'm running out of room, touches each edge once, ending up where it started. So ending up at the start. Just squeeze that in there. Okay, so now you guys can try the questions that are set out on the sheet.